Let's start with pseudo-asymmetric center. Pseudo-asymmetric center is an asymmetric center where asymmetry arises due to attachment of two groups having mirror image configuration of each other between them, but this does not give rise to asymmetry as dissymmetry as a whole. So it is a center where asymmetric center where asymmetry arises due to attachment of two groups having mirror image configuration of each other between them, but this does not give rise to asymmetry or dissymmetry as a whole. So this is your pseudo asymmetric center, and above it we have the mirror image of each other. Can you see these two? These two are the mirror image of each other. This one is the mirror image of this. So this is pseudo-asymmetric center. Can you understand? Yes. After mutual exchange and rotation, new stereogenic center and old stereogenic, non-stereogenic center, old structure. So after the mutual exchange of this, the old one is non-stereogenic structure and the new one is stereogenic. Okay, this is stereogenic and this is non-stereogenic. Next, let us practice some R and S. So you need to remember 4b plus, 3b minus, 2b plus and 1b minus. Okay, let's do. Now you have Br, H, I and this. So this is your back carbon. Okay, so first, so the highest atomic number is I, then is Br, then is fluorine, then is hydrogen. So 1, 2, 3, 4 priority. Now if I talk about how you will do, so the fourth priority is in back, so 4b, you will hide the 4b with your hand. So how it is going? 1 2 3, this way it is coming. So this is anti-clockwise, 4b plus, so it will be S. Now over here we have similarly 1 2 3 4. Okay, Y1 Br highest atomic number, Y2 Cl17, carbon is 6, so 3, and the hydrogen is 4. So always consider the first one over here. Okay, so 1b minus, first is at the back, hide it, 2 3 4 going this way, so it will be S, but it is minus, so opposite of here, so R. Okay, similarly this one you can check, similarly I have done. Okay, if you don't understand it clearly, you can comment. I will explain it once more in a single video. This one also I have done similarly. This one, Fisher. Okay, Fisher, if you have the fourth priority in horizontal, then opposite of the normal rule. If comes R, then you will write S, and if fourth priority is in vertical, then normal. If R is coming, then R. If S is coming, then S. Okay, so like this over here, O is 8, so first priority. Second, carbon is 6, so second priority. Now over here, carbon over here is second priority because carbon is directly attached to oxygen, so second one is 2. Over here it is directly attached to hydrogen, so this is third priority, and this is fourth, so fourth priority over here. Now hide the fourth priority. How 1 2 3 is coming? 1 2 3 this way, so this is S, but as the fourth priority is in horizontal, so this will get R. This way I have done this also. This is RS nomenclature. Okay, you can see similarly I have done this all the practices. Now this one is a complex one, so I am explaining it to you. Over here we have N first priority, C second priority because this is 6. This one total C is third priority because it is having oxygen directly, so this is second priority, and C is having hydrogen and OH with it, hydrogen with it, so this is third priority, and this is fourth. So 1, now you hide the fourth priority, you get 1 2 and 3 this way, so this is your S, and fourth priority is in horizontal, so the first part of this is R. This way you will take out this also, this will become S. Now pseudo asymmetric center, how will you take it out? Pseudo asymmetric center, you took out this one as R, this one as S. Okay, in the last example we did over here, top one was R, this one was S, so R has more priority than S. Okay, now O is the highest priority here, you consider the middle 1, this is 2, this is 3, this is 4. So now hide the fourth, so 1 2 3 this way it is coming, so this is S, but this is fourth priority at horizontal, so this will become R. So small r, pseudo asymmetric is denoted by small r and small s. Now I have shown you how to draw structure, because pseudo asymmetric don't come directly drawn into structure, this way it will be written, you have to draw the structure. So wherever the stars are given, that will be the direct centers. Okay, 3 centers. Now similarly, if this is the center, one side is hydrogen, one side is COH, other side is OH. So this way I have written OHH, HOH, HOH, COOH. So this way you can write. Now this one EZ I have done. If the you prioritize this, CH3 is more, 2 is hydrogen, this is 1, this is 2, so highest priority are in opposite, so this is E. Similarly, I have done a tough one also for you to understand. Like first I start with this one. So this is 1, this is 2, this is 1, this is carbon is 2. So both are at the same side, highest priority is Z. This one, let's see, we have carbon, carbon, chlorine, Br is first, chlorine is second, and over here we have carbon, we have one side carbon, one side hydrogen, so first, second, so the highest priority are in opposite, so this will be E. Okay, now CIP rule, can Ingold Prelog rule. Okay, this is, I am explaining it to you. First listen, can Ingold Prelog rule is the rule, like chirality rule only, that you in sequence you arrange the ligands attached to the chiral center, like CABCD. Okay, CABCD, you arrange this, A greater than B greater than C greater than D. This way you arrange, or 1 2 3 4. Now you look from the least priority, that is the fourth priority, in such a way that if 1 2 2 to 3 are shown in clockwise, it is R, in anti-clockwise then it is S. And also if the highest priority is sequential cis, that in the same side, then it is Z. If the highest priority are in the opposite side, sequential trans, then it is E. Now we have Falcon atom. Falcon atom, double bonded structure given, you convert it into single bond by this attachment. This is similar to this. This is called Falcon atom. Now we have, so now we are going to see racemic mixture. So first with an example, we are going to understand racemic mixture. So I took pyruvic acid reacting with hydrogen in the presence of catalyst palladium, nickel and platinum. Attack of hydrogen from bottom, we get hydrogen below, hydrogen on the above and OH on the below. Attack of hydrogen from above, then we get OH on the above and H on the below. Okay, this way we convert into a chiral. Now what is this racemic mixture? The process of converting chiral carbon or chiral molecules, the process of synthesizing chiral molecules from achiral, we get both the enantiomers in equal amount. So the plane of polarization of light is 50% of the mixture content plus enantiomer, 50% of the mixture content minus enantiomer, another type. So one try to rotate it towards the plane of polarization towards left, and other try to rotate the plane of polarization towards right. As a result, there is no optical activity of such compound. Exact cancellation of all the rotations occur. Such equimolar mixture of two enantiomers is called racemic mixture. And enantiomers have identical physically and chemically in a chiral environment, but they can be converted. Enantiomers are different in physical and chemical structure properties in chiral environment, so they can be synthesized in chiral with the help of chiral, in the chiral environment with the help of chiral reagent. Okay, so this can be a question for you. I am dictating it, you can write it nicely if you want. Okay, thus during the synthesis of chiral molecules from achiral ones, we get both the enantiomer are whole optically inactive as 50% of the mixture will try to rotate the plane of polarization light and 50% of the mixture will try to rotate the plane of polarization to the left in equal amount. This exact cancellation of all the rotations would occur. Such an equimolar mixture of two enantiomer is called racemic mixture, racemic modification. Racemic show no rotation of plane of polarization of light because they cancel out each other. And enantiomers have identical physical and chemical properties under a chiral environment. Enantiomers have different physical and chiral properties in under chiral environment. So to obtain one enantiomer preferentially, either we have to synthesize it under chiral environment, that is by using chiral reagent or chiral catalyst, or we have to separate the racemate in chiral environment, So you have to separate the racemate in chiral environment in order to obtain one enantiomer. Okay. Now we come to resolution. What is your resolution? Let's see, your resolution is what? So, if I say separation of the components of the racemic mixture into two different enantiomers is called resolution. Resolution is the method of separation of racemic modification into pure enantiomers. In practice, the separation is not always quantitative and the form separate may not be optically pure. It may consist plus or minus forms in unequal amount. Large number of methods of resolution have now developed and different nature of compounds need different method. So first is your mechanical separation. This involves the manual separation of racemic conglomerate contains enantiomeric crystals in equal quantities. Pasteur introduced this method in 1848 and separated to minus form of tartaric acid using sodium ammonium tartarate. So I am showing you a simplified form of these forms. First you get mechanical resolution, manual separation of crystals, sodium ammonium tartarate. Then we have biochemical resolution, selective metabolism by enzymes or microbes. In this we have example yeast action on lactic acid. Next we have chemical resolution, formation of diastereomeric salt, tartaric acid. Then we have chromatography, differential absorption on chiral column. We have GC example, kinetic different reaction rate of enantiomers. We have enzymatic hydrolysis. So this was your resolution. Now in the next class we are going to do only two topics, resolution of acid, resolution of bases, and we will complete the chapter with erythros and threos, short note erythros and threos, then your stereochemistry is complete. Okay.